stuff. Okay, so we're really getting into the whole object-oriented stuff. And this is part of the takeaways here, not just learning the Java language, but also understanding how object-oriented design and object-oriented programming works. So encapsulation is a very important concept. It's something that, you know, object-oriented approach has been kind of, it's a key element of object-oriented approach, and there's a very good reason for it. Visibility modifiers, again, this is something that the scripting languages typically don't deal with, but what visibility modifiers are key in understanding what encapsulation is about, because they help enforce encapsulation and enforce being live. So there's basically a conflict between keeping everything safe and making it do something. So we'll talk about that. And then accessors and mutators, or as I prefer to call them, setters and getters. And then we're going to dive in a little bit into what methods are, and just take a little bit of a peek at something called local variables that we've been using and not really commenting a lot on. Okay, so encapsulation, very important concept. So when the instructor says it's important, then it's important, so you should know it. The visibility modifiers, again, a key element to that. The accessors and the setters and getters. The NetBeans is a real helper on this. We've seen a little bit of this. If I get a chance to do some code, I'll kind of show you again how NetBeans will basically write these for you with a couple of clicks. And then so we begin to understand the structure of a method. You know, we've been talking about methods versus functions, and kind of methods are like functions, except that they're typically, the instance methods are attached to objects. And so we can't just kind of call a method. Okay, so there we go. So the thing with an object is that there are kind of two parts to it. There's the inside and then there's the outside. So there's the inside are the variables, or instance variables is a term I like. The book somehow doesn't seem to use that, but that's the term that I will use. And the methods that define it. So when we write a class, again, the class is a many-faceted thing. It's a template for stamping out objects. It's also a type that we can define a variable for, and other things. So what is in the object? Well, that's for a user-defined object, that's up to you. For the built-in objects, they're already designed. Now, so the inside, the guts of it, and then there's the external. And that's one way of looking at that, is the services that the object provides and how it interacts with the rest of the system, namely with other objects. And so a kind of a simple view of an object-oriented program consists of instantiating a bunch of objects and then having the objects send messages to each other. And, you know, being in the moves curriculum, I mean, at some point you will be, if you haven't already been dealing with, you know, agents and entities that kind of move around and interact with each other. And I hope that this helps you kind of see that this object-oriented approach is a very useful one if those are the things that you're going to be building in your program. So if you think of what an agent is, you know, it has an internal state. It has behaviors that interact with other agents in the model. And so in a sense, agents and objects can be thought of as kind of the same thing in this perspective. And we're not doing agent programming here, of course, but we're just doing regular old ordinary programming. but from an object-oriented point of view. So from the outside, the idea of encapsulation is that the state of the object, the internal workings, and especially the internal variables, is encapsulated. What is a capsule? A capsule is just sort of a hard container that keeps the outside from keeps the outside out and the inside in. Now, because the objects interact with others, the services, that is the methods, the public methods, they define an interface of the object, meaning that the interface are the methods that you can invoke from the outside. And the cardinal rule, the prime directive in object-oriented programming and design, is that an object never directly changes the value of an instance variable of another object. That's sort of the only code that should change the value of an instance variable is a method within the object itself. I mean, that bears repeating. The only part of the program that changes the value of an instance method, the data inside an object, is a method inside that object. The interface is how objects outside the object will direct the object to possibly change the state. So, okay, so, and we can sort of think this as a sort of a client server type of thing. So if I have one object can be thought of as the client and the other object for the service. So when one object invokes a method on another object, then in a sense, you're using that service. So requesting the service is equivalent to calling its methods. But it shouldn't have to be aware of how those services are accomplished. This is what I like to call the programmer virtue of ignorance and apathy. And that comes from the poll that they were taking. And they asked each person on the street, what do you think of the terrible problem in society of ignorance and apathy? And the most common response, of course, was, I don't know and I don't care. So the programmer virtue of ignorance and apathy is that when I invoke a method, I shouldn't know or care how that method is accomplishing what it does. In other words, all I need to know is what the Java doc tells me, what the documentation says. This is what it does. How it does it, that's not my business. And again, this bears repeating. Any changes to the object state, that is its variables, should be made by that object's methods only, nobody else. So if you want to change an object state, then you need to invoke a method on that object that will possibly cause that object state to change. And in general, the idea is that you want to maintain the integrity of that state. So, I mean, here's another metaphor. You know, think of turning on a light bulb. So, or turning on a light. So you have a light, and how do you interact with it? Let's say it's like the light in your room. So what do you have? You have a switch, and the switch turns it on or off. You don't go to the light and basically take it apart and kind of start mucking with its innards. The interface of that light is the switch. And as the client of the light, you are only allowed to, well, I mean, if in manipulating it, you can turn it on, you can turn it off, or if it's a dimmer, you can make it dim in between. And as a user of this light, that's really the only thing you can do. Okay, so just in general, and you know, we should think of the object as a black box. You know, what is going on the inside? That's not the client's job. Now, well, of course, now when you're as the developer, as the programmer, when I'm writing the class, then of course I I put in what data I want, that is the instance variables. I write whatever methods are required to manipulate this object. But what this figure is showing is that here's that this client is some other object. It only interacts with the methods. It does not touch the data itself. Okay, so this is something which tends to be different than what you may have been used to in the scripting languages. Scripting languages are not oriented towards encapsulation. So this may seem, it may seem like a lot of extra work. And it is. It's a little, well, it's a little bit of extra work. And there's a really good reason for it. The reason for it is that by keeping your hands off the data, it maintains the integrity of the data. And so if something has mucked with your data, if the data has somehow changed, or if the state of your object has somehow got into some weird place, there's only one place to look, and that's within the methods of that class. That's the only, if you maintain this, that's the only place to look at it. If you allow other parts of the program to change that data, then it can be looking for a needle in a haystack. Okay, so how is this maintained? When we write an object, how do we say, okay, this you can see and this you can't see? That's what a visibility modifier is. Okay, so these are Java words that specify a particular characteristic. We've seen the final modifier to define constants, and again, for some reason the book likes to define constants as instance variables, which is fine. There's nothing inherently wrong with that. It's generally better style to define them as class variables, that is static with static. So if you notice, when I've implemented re-implemented some of the book's examples, I will typically take one of these constants and make it a class method, a class variable, sorry. Okay, there are three visibility modifiers, and then there's a fourth, which is nothing. And that should never be used. Okay, so public and private are the two that we will mostly deal with here. There's a third one called protected that you will actually encounter next quarter in the simulation class. For a variety of reasons, protected turns out to be useful there because it involves inheritance, and we haven't talked about inheritance yet. So for right now, public and private are really the only two visibility modifiers that we will be using here. Okay, so what is the difference? Well, public can be referenced anywhere. We've seen most of our methods have been defined with public visibility. And so if I define a method with public visibility, that means that anybody who has a reference to that object can invoke that method. Now, members of when I say they say members, members thing about either data, the instance variables, or the methods. So private visibility can only be referenced by an object of that class. In other words, the only code that can access something with private visibility is a method within that class. And now protected can be referenced by subclasses. What are subclasses? We'll talk about that later. So for right now, don't worry about protected. If you declare it without a visibility modifier, that's called package access or default visibility. And that can be referenced by any class in the same package. And that is something which should not be used. For historical purposes, it was something that Java put in the very beginning. And since people used it, they decided to leave it in. But you should never use that. You should always have an explicit visibility modifier. And for our purposes, they should always be, in this class, they will always be public or private. So every variable, every instance variable will be private. Every instance method, well, almost all will be public, and occasionally we'll have a private one. But for now, the rule of thumb that will be useful is to have instance variables be private and instance methods be public. If you go with that rule of thumb in this class, then you'll be right about 99% of the time. So public instance variables, see, they violate encapsulation because they allow any other object to modify the values directly. Therefore, you should never, ever have public visibility in your instance variables. And that's, if there's one mortal sin in object-oriented design, this is it. So so basically, if for whatever reason, just by mistake or fat fingering or whatever, if I see a public instance variables, and that's sort of an instant dinging. Now, constant, we've seen constants, and again, I prefer static constants. It's okay to give a constant public visibility. Why? Because it's final. You can't change its value. So it's okay to let anybody see it. There's really no harm in that. Instance variables, though, typically are not, if they're not final, then they can be modified. And if they can be modified, then the only things that should modify them are methods that are inside the class. Okay, the methods, they're declared with public visibility. Otherwise, if they're not declared with public visibility, then they can't be invoked. So the whole point of the methods is that they provide these services. Service methods. I don't tend to use that term. That's something that the book likes, but again, it's a fairly descriptive term. Now, sometimes they're calling them kind of support methods. In other words, sometimes internally, here's where it comes up. Here's where I will typically use it. Within a method, there might be some kind of complex calculation that you have to do. And so rather than putting all of that, and if that's in the middle of some other logic in a method, if I'll typically take that complex calculation and move that to a private support method. So instead of kind of jamming all that code into one method, I'll simply call this support method. So the support method, it's not something that you can call it outside, so you don't declare it with public visibility. We'll declare it with private visibility. There are some occasions where you might need protected, but again, we're not dealing with protected yet. So for most of this class, be aware that protected exists, but we're not going to worry about it until next quarter. Okay, so this is a nice way of just kind of visualizing what's going on here. So we have variables and methods. So a class consists of variables as instance variables and methods. The methods, and they can be either public or private. So a public instance variable violates encapsulation. It's in red. You never do that. All of our instance variables will be private because that enforces encapsulation. Okay, our public methods, they provide services to clients. And our private ones, they support other methods in class. And again, the biggest use case is for some complex type of code that's in the middle of logic for another method that you want to just kind of, just for visibility, just for a variety of purposes, you want to kind of put that somewhere else. It'll probably be a while before we encounter the need for that, but just be aware that that exists. Okay, accessors and mutators. I prefer the term setters and getters. So okay, so here's the dilemma. We have instance data, and because it's private, how can it ever change? I mean, there are some situations where you have instance variables that you don't want to change. So, for example, one example we'll see tomorrow is if we're modeling a bank account. Actually, I think we kind of had an example of that. The things like the account number would be is something that we wouldn't want to change. And maybe the name on the account is something that we also don't want to change. But the balance is something that's going to change. So how do we change how do we change that? Well, again, accessor, which is a getter, or mutator, which is a setter. And Java has conventions for that. So the getter will typically say get blah blah, and the setter, the mutator, will say set blah blah. There's actually there's one exception to that, and if you have a Boolean variable, the getter will typically say is X, just because it sounds better. Okay, so the what they call mutator or setters, and so that gives you the ability to modify the object state. So if I have an instance variable, and I'm going to say, well, okay, I'm going to allow any client, any object which has access to this, to be able to modify that variable by setting it to a certain value, then we create a setter or a mutator. There are situations in which the setter will constrain the values. So now the reason why the book had this setter, I think, was just to kind of have this example. So if a die could only have values 1 to max, and you're going to allow somebody to kind of cheat and just sort of set the value, then the problem is that the argument to the setter, in this case, the argument would be an int, so you would pass an integer value to this die, and the setter would set the number of dots to that value. The problem with that is that the die is only allowed to have values 1 to max, and max happened to be 6 in this case. So if you allowed this, and as I said, it is not a good design to allow this, because this is basically cheating. But if you allowed this, then what the method should do is it should reject any attempt to set a value that is not in the range. Here's another example, and this is an example that we're going to encounter next quarter. Let's say we're modeling, the program is modeling a service facility. And one of the instance variables is the number of servers that are there. So think of like a bank. You go to a bank and then there are a bunch of tellers. So if we're modeling that, then one of our instance variables might be the number of tellers. Now, if we have a setter for that, the value, the argument would be an integer. So if I say, okay, I want to have 5 tellers, I would have set number of tellers. So I might have set tellers. And again, I would give an integer and just some dummy argument. The problem is that this needs to be a positive number, or at least a non-negative number. So if I were to say, okay, give me -3 tellers, I mean, what the heck is that about? So this setter method should reject any negative value. So that, in other words, instead of just passing the value through, you would have to test it to say, okay, are you within the legal range? And if not, then actually you want to do is throw an exception. We'll talk about exceptions later in the class. Okay, check. Why was the face value declared as private in the die class? Because the die was to control its own data and allow it to be modified only by the well-defined operations it provides. And as I pointed out, the setter method was actually a violation of sort of logic of this. It was okay to declare the max as public because it's a constant and it can't be changed, and so it's not a violation of encapsulation. Okay, before I charge on, are there any questions? Okay, so this is all clear. Am I beating a dead horse here? All right, so let's dive into methods in a little bit, because basically the design of a class and writing a class consists of defining what your instance variables are and then defining what your methods are. End of story. So that's so we can declare victory and end the class early in the quarter. No, so there's a bit more. Okay, so the method declaration, when you are the author, when you are the programmer, you decide which method. It's up to you to write, to decide which instance variables there are. It's up to you to decide which methods are going to be invoked in order to do stuff. When you invoke the method, then what happens is the flow of control jumps to what that method is, executes its code, and then returns to where it was called. So if you're used to programs, and scripting programs tend to do this. In scripting programs, you start at the top of the page and you just kind of work your way down to the bottom of the page line by line. In object-oriented design, it's a bit more nonlinear. So it's important to understand that difference. I know my first programming languages were very procedural, and that I was sort of used to that linear flow. And so just one of the things that took me a little while to kind of wrap my head around was the fact that this nonlinear flow is what happens in object-oriented design. Now, when you call a method, it may or may not return a value depending on how the method is defined. And then even if it returns a value, you don't have to do anything with that value. So, if and this is something which I've kind of debated about whether that's a good idea or not. Whether it's a good idea or not, Java allows it. So if I call a method that returns a value and I simply don't even put that value anywhere, then Java says, okay, fine, you don't care. I'm good with that. Okay, so here, now notice a little So if, okay, now how do we call a method? When we call a method, if it's in the same class, then I only need the method name. So if compute is a method in the class and my method is another method in the same class, and compute is kind of going along here, and then at some point it calls my method, then I can just kind of call it without anything. And what happens? Well, basically, you follow the arrows. It goes into my method executes. When it finally returns, you pick up from where you left off and you keep going. Now, if I call it from another object, from another class, then I need to be more explicit. So let's say if I'm in my main, coming from my main, and obj is an instance of this particular class right here, then I need to explicitly say invoke this method on this object. And what it will do is it will go to that object. It will go to this method, the doIt method. It will start executing. Now here in this particular implementation, in the course of the doIt's method, it called a support method called help me. And so the flow of control, doIt is kind of processing line by line. And then it hit help me and said, and all of a sudden control jumps to help me. Help me executes, returns to doIt. It finishes executing and then finally returns to main, and then main keeps executing from there. So here's the way to take what that kind of line by line top of the page to the bottom of the page that many scripting languages have and you might be used to, and simply kind of deconstruct that a little bit and apply it to within each method. That is, within each method, that's the rule that follows. So if we unpack this, the help me method starts at the top of the help me method and goes to the bottom of the help me method, where it then returns. The doIt method goes from the top of the doIt method to the bottom of the doIt method, although in between it kind of took a little detour. And even the main method starts at the top, executes line by line. In this case, it hits a detour, goes to the doIt method of this particular object, which in turn took another detour to the help me method, returned, finished the doIt method, returned here, and then finished the main method. Okay, so the method header is how things are defined. Now, and if you define functions before, then this is pretty much the same kind of thing. The difference being that if you're used to an untyped language, you don't need to define what type of things they are, because Java is a strongly typed language. Everything has to have a type, everything. So this what they call the parameter list, sometimes it's called the arguments, or sometimes it's also called the signature. I'll use all of those various terms. The important thing isn't the name. The important thing is to understand what they are and what the pieces are. Okay, so there are three parts to a method header. Well, one is the name. The second is the parameter list, which could be empty. So you're allowed to have an empty parameter list, as you do with functions. And then the final is the return type, which can be either it can be a built-in type. In this case, it's a primitive. It can be any class that is anywhere. So it can be a built-in Java class like string, or it can be a user-defined class. So any type, or it can be void. If it doesn't return anything, you can say void. Okay, so the names are, the names of these things are kind of, well, they're only important on the internals of the method. So the second part of the method is the body. That's okay, here's a method, what does it do? The body of the method is enclosed in the curly braces that immediately follow it. Now here the book has this form, I do the other form, again, whatever you prefer. Okay, the strong typing means that the return has to be consistent with the char. In this particular case, it returns a character, and that means that the result must be a character. It can't return anything else. It can't return an int, it can't return a string, it can't return a void. It can't return anything but a character. It must return that an expression. Now say an expression. In this case, the expression is just simply a single variable. You can return a whole expression. Okay, so now here's where we're starting to look at the third type of variable. We have seen two types of variables so far. We've seen instance variables, and we've seen class variables. And the third type of variable are local variables. So local variables, we define those. A local variable is, we simply define it. Now notice that a local variable does not have visibility modifier. Again, local variables do not have visibility modifier. I can't say, in fact, I can't say private int sum or public int sum or anything else. Why? Because something called scope. The scope of a variable is within its curly braces. So this sum and this result exist only in a single call to this method. In one call to the method, these variables are created, and as soon as you return from that method, they go away. And then if I call the method again, these variables get recreated. So these variables, these local variables, do not persist from one call of the method to the next. The variables that do persist from one call to the next are the instance variables. Now so local variables have a scope which is only within a single call to the method. Now, what about these arguments? The parameters to a method likewise have scope only within a call to that method. And we'll see, if not today, maybe tomorrow, that can produce some little gotchas if you're not careful in really getting what that is. In other words, we can think of local variables as, we can think of these parameters as local variables. And so their value does not persist from one call to the next. Okay, the return type, that's the type of value that the method sends back. If it doesn't return a value, then we say void, and then you can't return a value. And as we said, when we say return, just as we did here, when we said return result, that result had to be a character because we said that the character was the return type. So that's when we say that the expression must conform to the return type. Okay, so when we call that method, so here I'm calling the method, with a constant. Here, presumably, the count is an integer which has been defined somewhere up here. Here's a string. And these values get copied. And this is something I'm going to be kind of re-emphasizing, because the different languages have different conventions about this. If you've heard the term pass by value and pass by reference, and it can be very confusing. What Java did was Java just simplified all of it. So, but in that simplification, there are some gotchas here. So, okay, so let's say that count was, I don't know, 3 or something. And now this is kind of an interesting one, because this is actually going to return an error. So let's make instead let's call this with, say, 1 and 3. All right, so now what this is kind of this is a weird method. So what it does is it takes the first 2 arguments, adds them together, and returns the character at that sum. When the first argument is 25, the string that's passing only has 5 characters. So this would produce an error. So, okay, so what happens? These values get copied in here. And so we can treat these like these are like local variables. If I call it again, then with different values, then that's just what it gets. So these values get copied in and then executed. So I have, okay, I think I have time to, well, no, I don't really have time.